Hello everyone, the given question is from the topic of collision. So we can say it is from work, energy and power chapter. It is from JEE Advance 2018 paper 1. It goes like this. A spring block system is resting on a frictionless floor as shown in the figure. The spring constant is this and the mass of the block is this. Ignore the mass of the spring. Initially, the spring is at unstretched condition. Another block of mass 1 kg is moving with a speed 2 meters per second elastically collides with the first block. The collision is such that the 2 kg block does not hit the wall. The distance in meters between the two blocks when the spring returns to its unstretched position for the first time after the collision is. Alright, so the question is saying that there is this guy. It's moving with 2 meters per second velocity, and this guy is at rest. Okay. Now when they collide, okay, there will be some velocity given to this, and this guy will start moving in opposite direction with some velocity. The mass is less, so of course it will move in some opposite velocity. Alright, now it has some velocity, so it will go back and it will come here. Okay, so we know the time period is independent of the velocity, so we can say that the time taken is equals to the time period by 2, which is pi by root of k by m, right? I guess it is k by m, say, or m by k. So anyways, both are same, so it is basically pi. Okay, so this is the time here, and once you know what is the velocity with which this guy is traveling after this, you just have to multiply it with the time, and then you will get your answer. Okay, the distance between the two blocks when the spring returns to its unstretched position, matlab ye wapas, so this guy is again coming to its original position, and then how much does this travel, does the 1 kg block travel at the meantime. See, there are three methods of doing this. Okay, method 1 is solving equations. You know, there are two equations. You'll get that E is equals to V2 minus V1 by V2 minus U1. Okay, and then there we have M1 V1 is equals to M2 V2, conservation of momentum, right? And then second method is that with these two equations you can remember, you can memorize the velocity formula, what you get. Okay, so M1 is this, M2 is memorizing the result. The second is method 3 is solving in the reference frame of center of mass. Okay, so for this what we do, we first calculate the velocity of center of mass, which is m1 v1 plus m2 v2 by m1 plus m2. We'll call this vc. This is equals to, in this case, 2 by 2, 1 plus 2, which is 3, 2 by 3 meters per second. Okay, right. Right now, if we see this is the center of mass, and the blocks come here, is coming here at a speed of 2 meters per second, which in reference to center of mass is this, so it will be 4 by 3 meters per second. Okay, and then it will go back by again the same speed. Okay, minus 4 by 3 meters per second, and this guy, this block 1, block 2 is coming at a velocity of 0 minus 4 by 3, 0 minus 2 by 3 meters per second. It is coming at 2 by 3 meters per second, and it will go back by 2 by 3 meters per second. This is all happening at the frame of the center of mass. Okay, now if you want this to be in ground frame, we basically add. Okay, we add the velocity. Okay, and this will be minus 2 by 3 meters per second. All right, now once you find this, the distance will be equal to 2 by 3 times pi, which is 2.09 meters. So the answer to this question is 2.09 meters. All right, thank you.